Okay, so first of all, welcome everyone. Welcome to this webinar where we will be talking about the unlocking of the value of generative AI in financial services. Very topical, the topical issue, I think, where there's a lot to discuss. And luckily, we have a few very knowledgeable people here in the room for today. From our colleagues from Evalueserve. So first of all, we have Anna, who is global leader for risk and quant solutions. Satya, who is the global head of technology and digital solutions, and Sundar, who is director of financial derivatives and risks. So we will be able to cover this generative AI topic from many different directions, which is, I think, a very important point. So for today, we are going to try to make everything as practical and concrete as possible, meaning that we will start by giving a few real-world use cases of GenAI, talking about the success stories, but also definitely focusing on what is challenging and where we want to, or where there is opportunity to improve. And then, of course, as I'm always slightly biased to talk about risk and especially model risk and AI governance, we will also talk a bit about those topics, trying to highlight what are, say, standardized approaches that can be used to manage properly the risk of generative AI. And of course, I hope we have enough time, and actually I'll try my best to make sure that we have enough time to have plenty of Q&A. So please, if you have any questions, do not hold back. You can always post them in the chat, and we will address them whenever we are in the third part of this session. Now, to get started, we are going to talk about generative AI, and of course, generative AI makes everyone always slightly uncomfortable, I would say, because of course the landscape is evolving very fast. These are very new tools. If they are used, say, in a professional context, sometimes one even doesn't really know if you should share whether or not you have used ChatGPT to create an email, for instance. But also, generative AI itself is often confidently wrong, right? We are all used to having ChatGPT talk about something that is actually definitely not true, but it does this in a very confident way, and it's very strange to see this behavior. And of course, as a consequence of this, assessing performance is extremely important, and organizations are still figuring out how to do this properly. And these observations really have been confirmed in many studies. One of them is the 2025 Outlook by IBM, where it was stated that over 60% of banking CEOs say that they must accept significant risk to harness automation. And of course, that automation is often driven, at least in the vision, by generative AI tools and use cases. While simultaneously in the same study, it was stated that 78% of banks only had a tactical approach to GenAI. So as you can see, even from the risk point of view, this is definitely a topic that makes many leaders, many executives quite slightly uncomfortable. So that's why we really would like to talk a lot about those topics. In order to frame the discussion, let's start maybe with a poll. And this is going to be the first of 3 polls for this webinar. And here we would like really to ask you to say where you see your organization today in terms of AI maturity. So meaning, do you consider yourself a beginner? You're exploring the right use cases, maybe trying out some pilots or POCs. If you're an implementer, then it means, okay, we have really accepted a POC and are now running the application in a very specific context, an early rollout really. Or do you consider yourself a leader, meaning that you are using GenAI already at many different places in the organization, and this is really integrated in the overall workflow and the different workflows that happen in your organization. So, of course, we are very curious to understand your points of views. So let's give everyone still a minute to consider the classification. Okay, so I see quite a few people have already voted, and yes, so what we see here in the audience is that quite few people consider themselves a leader or consider their organization a leader, which aligns very well with, say, a recent KPMG benchmark, where it was stated that only a small minority, like less than a quarter, has reached a leader stage. And moreover, only 75% within that, that leader segment actually had already properly implemented responsible AI principles. So this really confirms the fact that there is a huge amount of work still to be done, a lot of lessons to learn, be it in designing and implementing generative AI applications, but definitely as well in the risk management of them. And that's exactly the topic of today's webinar. So let's definitely get started and start talking about real-world opportunities. So maybe a first question to Anna. So as you have been working already on these use cases, implementing those use cases, where have you seen already GenAI put to practice? Where have you seen it work? And what are, say, the key aspects that we have to take into consideration there?
Okay, super. Yeah, thank you, and thank you for having us. I think it starts with poll number 2. So let's hear from the audience, but I will then walk us through some very concrete examples and use cases and lessons learned. So the question is in the window now, which generative AI use cases are you guys exploring in your workplace? There is a reason why these answers are grouped this way, but we start with the credit and underwriting, model risk and governance. We will definitely come to this topic with Jos later in the presentation, investment management, private market insurance. Okay, I will let it run. I was expecting, to be honest, because I don't know what I was expecting. I was probably assuming that it will all be one, and then all my use cases will become obsolete other than one use case. But I'm delighted to see that it covers multiple parts and multiple functions. So where are we seeing the use cases, and what are we seeing in the market? I think, can we pause the video for 1 minute? Let me talk to what's going on, and then we move to the video. So we have seen all of these use cases out there now, investment management showed up as well. We have seen successful use cases and implementation across all of these different buckets as listed here. We will start with a little video of how we approach the topic, and then I will go through very specific deployments and where in the process we fit. Because I think one of the lessons, kind of about 2 lessons we want to bring in here, which is one is making sure that to unlock the value and unlock the potential, the use case is very specific and very domain specific and kind of fits for that business need. The second one is making sure that adoption is there to drive the value from it. So now, if we can get the video up, and we can go through these. Okay, so hope it plays. I think it is a little bit faster than I wish. Perfect. Let's start with what happened here on the screen and kind of what we are doing. So we start by combining internal data, because I think one of the key elements of making sure that the use case is solved is there's a lot of internal data, can be numerical, can be text, and there is third-party data, external data, can be from paid sources or unpaid sources, but it's always a very curated set of data sets. And that data then goes through what was there as a GenAI engine, I call a GenAI powered engine, and comes back with the risk assessment. Now, what we see as an absolute must in that process is keeping that human in the loop, because that assessment by itself cannot solve any problem. And while the process may be similar across different use cases, making sure that there is a very clear interface and the process that allows the human to go through all the answers that GenAI engine tried to answer and approves them, comments on them, and it is the human that makes the decision. We see that process work in insurance. I think I'm very excited because we just, about 15 minutes ago, we just learned that we are the finalist for the InsurTech Award with the platform you guys just seen, where we provide augmented insurance underwriting, which is taking the data and a huge amount of quantitative and qualitative inputs and putting it through that GenAI engine, and then finishing the process with a highly skilled underwriter who makes a decision and writes on analysis. So that is first use case. Second use case, so that kind of covers that insurance bit. Okay, that's very helpful. So internal data, like credit platforms. The second use case is around the early warning signal and credit underwriting. We have use cases around credit memo. One will pivot here is early warning signal, which is taking the universe of data and feeding it into signals that willingness to repay, increase in credit risk, and really augment, supports, and continuously monitor the market for any signals that could cause change in staging of that obligor. That then swiftly falls into a nice workflow for the staging and IFRS reporting. I'll pass on to Satya to go through the whole logic of it and how we put it in technology. I think there is certain themes that we hear from all the clients around, will a GenAI work for us? Is this the right technology for that use case? Is my data safe? Where is the data you guys using?
Yeah, no, thank you so much, Anna. So, early warning signals, which Anna just spoke about in the context of credit staging, and just go back one slide, yeah. The example that Anna spoke about, right, in the context of credit staging for obligors. So since the advent of generative AI, early warning signals scope has been increasing, just because of the way LLMs are interacting with web data, alternate data. So in addition to the use case that Anna gave, other examples where early warning signal is being leveraged in the financial services world includes monitoring portfolio companies in private equity firms, risk assessment, credit risk assessments, relationship managers tracking the client profiles for either credit staging or proactive engagement, strategic forward-looking insights to adjust risk appetite, lending strategies, sectoral exposures, macroeconomic risk monitoring, right? So the use cases in financial services for this one AI-focused pipeline is immense. Early warning signals and early warning detection has been a use case that we have been trying to figure out for many, many years, even before the advent of GenAI. We leveraged traditional AI and NLP models that sourced information from the internet and then applied deduplication, noise filtering, summarization on the data to be able to give the results. But prior to GenAI, when this was being done, leveraging the traditional models, the challenges were around scalability, comprehensiveness. There were challenges around noise, just so much of noise in terms of the data that you're getting through, right? So with GenAI, what we have done is we've been able to apply certain fixes to this process to be able to get better and more curated market insights that feed into this entire workflow that Anna spoke about. So two things that are critical when it comes to early warning signals and GenAI. One is making the AI engines that leverage LLMs understand what it needs to capture or not. So making it very contextual. and two, ability for the engine to capture multiple sources of information. So in order to bring the right context, we focus on something called a mind map. So if you go to the next slide, what a mind map actually does is it creates a series of triggers and sub-triggers at a company and sector level. So let's say there are certain questions you need to answer, like are there challenges in the customer sector? Are we seeing senior level exits? Is there a downgrade or negative outlook? Is there discontentment among employees, right? These are questions that are very critical. And to be able to answer those questions, what we have done over the years is created this mind map. And here you see a very, very small sample at a sector level and company level. Things like declining occupancy rates, high vacancy, oversupply, property value drop. On a company's side, you're seeing management change, board member change, etc. Right? So these triggers and sub-triggers are fed into our AI pipeline that talks to the LLM and extracts information from the market, over which we then apply all the necessary filtration and tagging. What we also need to do in the process is apply guardrails. So, for example, what are the negative triggers that should be avoided? Include sources that should be avoided. There are clients and firms who do not want social media inputs, as I say, is not trustworthy, right? So how do I ensure those guardrails are there? Add sources that need to be prioritized, right? So with GenAI, what we are able to do now is define the triggers, define the prompts, generate the answers to those questions that I mentioned. For example, are there challenges in the customer sector? The ability to answer that with validation and citation so that you can go back and cross-check. That is doable, and it's possible to do it at scale. It is possible to do it with greater accuracy, cost, speed, etc. Right? So I think this use case of combining internal and external data with the advent of GenAI has just become a lot more real, and it works really well. And you're able to do it in a very comprehensive manner. Another use case where you're looking at public data is in the area of corporate actions in the world of index. And I'll hand it over to Sundar to talk a little bit about that.
Yeah, hello everybody. So I hope most of you understand what are corporate actions. So for a simple example of a corporate action is, for example, a dividend. The record date, ex-date, the pay date and stuff. When a dividend is declared, the price of the underlying equity has to be adjusted, and so that it reflects correctly in index. Now, this is a perfect case for generative AI applications. We must first understand where the generative AI is actually applicable, where it fails. For example, construction of an index, which is for a custom index or something, can be quite complex because it may involve nested loops and logics. There, the generative AI may fail because of hallucinations and stuff. And it requires extreme rigor. But this is a perfect example for generative AI because this is based on text search, and the LLMs are naturally able to capture such stuff. So Evalueserve, and this is also a case where it comes to a fore that many people want to try a lot of stuff, but because LLMs are available now, these things are becoming easier now. So what is the application here? So constructors and maintainers have approached us like in past few months that do we do something on corporate actions, maybe to verify with the Bloomberg data or Refinitiv data, or maybe a cheaper source or stuff like that. So what we are doing here is we are leveraging parallel AI with custom prompts and stuff like that. And since it is a natural extension for large language models, the parallel AI can search for example, let's say Apple, it can search for 5 or 7 different websites and put everything together, all the corporate actions related to Apple for a particular date. So instead of doing it manually, first it searches for all the websites available, and then it also rates the websites. For example, if it is an investor relationship website of the Apple itself, if it's an investor relations website, it will rank it as a number 1. It's a very important website like a NASDAQ website or something, it's still 1. And in news ratings and stuff like that. So we have 3 scale of 1, 2, 3, where how the websites are ranked. On top of that, it also filters out the outliers. For example, if the 4 websites are giving you one particular amount for a dividend, and the 5th one is there's the outlier, it actually removes that out. Not necessarily it's wrong, but at least we can have a double cross-check around it. Now, how do you actually make sure that this is correct? So what we have done is, instead of using just one So one is the base LLM which you are using, and we have also used another LLM to compare these two things, and we also used the actual data provided by established vendors to compute it manually for S&P 500 and Russell 2000 indices. And almost 95% accuracy is guaranteed on the LLMs. There are minute errors because of how the prompts are sent. For example, some record date was not being read properly because the prompt was only using X date. Once you fix that, it is almost 100% correct. So this is the overall overview of what eSale, which we call as our trademark corporate action intelligence layer. This is a part of a whole index workbench solutions which we are creating. This thing can be hosted on Evalueserve environment or on the client's environment as deemed necessary. And the further processing, which is needed for index rebalancing, index adjustments and stuff like that, those are, since those are proprietary, will be hosted on the client's environment or an ORC. So that separates its public and the private domains.
Okay.
So I hope.
Thanks a lot. Thanks a lot, Sundar. These are indeed three very good use cases. Now, in the interest of time, and since we have quite a few more topics to discuss, I was wondering, maybe we want to explain a bit what are, say, key learnings, and also what are, say, those use cases where you see most strategic value. Maybe if I could ask Sundar first to explain a bit, say, what would be, according to you, the key learnings, and then Anna to talk about, say, what are future use cases, so that, say, in 5 minutes or so we can move to the next topic. So thank you. So Sundar, first up to you. What are, say, key learnings when it comes to generative AI? What works, and where do you see most challenges?
I think we start with Satya, because it starts with technology.
Yes.
Sorry, Satya.
Absolutely. So I will keep it very short because, in the last 2 years, you've learned the number of learnings, right? So first and foremost, not everything is about GenAI. I think old school automation works well in multiple cases. Both the examples that Anna spoke about and Sundar spoke about, while you can leverage GenAI, there is a lot of internal data that needs to be still assessed using rules, using the older way of doing analysis, right? So I think not everything is about GenAI, and a lot of our clients come back and say, we want to solve a problem using GenAI, right? So that's the first. The second one is around your architecture. In most sectors, you assess the architecture in the end after you do all the POCs and everything. I do believe in financial services world, you should first decide your architecture. You should decide from the start, where will the data be saved? What LLM is going to be used? Is it on-prem? Is it on the cloud? Is the data going out of training, etc.? Because otherwise what will happen is you will have a fantastic POC and it will be absolutely impossible to move off the ground. And we're seeing that across multiple clients. So it's important to get the architecture right and then move on to trying to solve the POC. And the third learning is around AI endearment. We spoke about it in a few ways. Make your AI pipeline contextual. The first output looks fantastic. I think, Jos, you mentioned about how it provides responses in a very confident way, right? That is endearment because it's not always accurate. So you need the domain in the loop. You need to ensure that it becomes contextual. There are examples in the world of financial services that we've worked on, but right now, in the interest of time, I won't go into it. But these are three learnings, that I would definitely want to highlight. Anna, anything at your end?
I'll start with the adoption. Actually, I have a few lessons here, but I'll put this one at the front. I had this when I was writing my notes. It's like it's not UAT, it's UAAT. It's acceptance testing and adoption testing, which is you are really trying to solve a business problem. And I think we have, sometimes they say, it's all about technology, but technology is not a strategy. You have a business problem, you're trying to solve it. This technology unlocks a new solution to problems that maybe was not solved before, or combined with a more traditional automation, more traditional workflows, can actually create a very compelling new way of doing things. But it only works if it really solves that problem. We understand the problem, we solve it well, and the user are adopting it. For Insurance One, the one that I just mentioned is shortlisted for the insurance awards, our adoptions level 100%, which means the users do not do things another way. This is this is the new way of learning how to underwrite. This is the way to underwrite. This is the way to do analytics. And that for me is a successful project. The next piece is around the human in the loop. I think for us, this layer of making sure there is the human validation, human review, there is an expert part at the end, is stopping that. You guys talked about the endearment, making sure that we don't expose ourselves to risks. I remember being in one of the panels last year, and someone said, you want to deploy GenAI, which is this unproven sometimes technology, to situations where you're dealing with experts who can actually assess what it's proposing and make sure it captures before these errors get released. You don't want to put it in front of the client. You want to keep that control. There was a lovely quote. One of our clients said that GenAI can collect all the dots, but not all dots need to be connected. Like, this doesn't work. So that governance piece is very, very important. But I think, Jos, you can talk to us about governance even more. I will. Can I just one final stat? Because I think we work with clients in model risk management, which is one of these topics on the list here as well. And we typically see clients have below 5% of AI GenAI models. We have recently seen a case when there is a massive leapfrog with technology, and that is 50% of the models are AI and GenAI just now. That is a completely new world, and the world in which we will have to adopt to, and the model risk management teams will have to adopt to. So, Jos, now to you, how is that world adopting?
A very good question, Anna. Thanks for asking. So indeed, I would say that governance need to evolve, but governance actually gradually evolves already. And where I believe most challenges lie are in the engineering part when it comes to model risk management. We are all used to a space with a limited number of models, where models also evolve fairly slowly over time. And to your point, you might have suddenly 50% more use cases in your inventory, and they need to go through the same process. This can only scale if you have technology to back this, and this comes with certain engineering questions, and this is going to be, say, one of the key points I'd like to focus on. But maybe before I start on that, we can already run our final poll, which is related to what are, say, the key barriers that our audience sees when it comes to implementing and rolling out generative AI and actually properly adopting it. Is it mostly related to skills or talents? Is it rather, say, the architecture which we discussed, or say legacy IT that is hard to overcome? Is it more related to governance or compliance, which is obviously a lot more complex? Or are you actually looking for the right business case? Because indeed, you want on the one hand side to automate things, but simultaneously, if human in the loop is that important, then obviously you need to balance this, right? And this is not always easy, and it's not so straightforward to find the right business case. So really curious to see what our audience thinks here. Okay, so far it's mostly about skills and talent and on governance and compliance.
Jos, I think that might have been the first poll I've seen when the legacy IT is not blamed for something, but that's now gone.
Yes. Well, when it is about generative AI, there is very little legacy, right? If you have 20 years of experience in generative AI, that's a bit hard. Okay, so it looks like governance and compliance is a hot topic for our audience. I would definitely like to agree very much. So thank you. So let's then go to, say, the discussion about how to manage those risks and how to implement this. So we talk a lot about hallucinations, definitely, but there is this other topic about sycophancy, right? If we talk to ChatGPT, it will always first of all state what a great question you have asked, and this is why I wanted to introduce this comic here, because I often feel a little bit like in this comic when I'm working with ChatGPT. It's hard to find this balance, also to fine tune or to create an LLM that asks the right level of questions and is a bit critical to the questions that are being asked, as this leads to quite a lot of challenges. And a bit related to this, as the example that I gave in the next slide, which is obviously slightly less funny, but kind of very important. A few months ago, Air Canada was fined because their chatbot was giving wrong travel, like wrong information related to the travel policy of the company. And it actually just invented, of course, it invented the policy, and therefore people were badly impacted by that information. Now, if we would do a kind of post-mortem analysis, which is something that we like to do in a software company, then like if we look a little bit closer, then actually this is not so much a governance problem. Of course, there needs to be governance around implementing a chatbot, but it's to a large extent as well an engineering problem in order to efficiently implement the governance itself. So what do I want to say here? Well, so first of all, what happened is that the chatbot hallucinated, right? It gave incorrect information. Now, how do you actually manage this? Because transformers, LLMs, they are simply predicting the next most likely token, of course, using a very complex algorithm. However, they are not truth seeking, and therefore you need to somehow implement guardrails. What do these guardrails consist of? Well, the most important guardrail, I would say, is to be able to control the context in which the conversation happens, and this to control in real time, say, what are the questions that are being asked, and verifying that, say, this is closely related to the knowledge that the chatbot has. This is in the first of all an engineering problem, and this is really what makes generative AI quite a big challenge in order to implement it in a robust fashion. So if we then go to the next slides, then this is really, say, my main message. When we are talking about AI governance, AI model risk management, there is not really a single denominator currently for this topic, but then there's a lot of talk about, of course, better governance. And of course, this is extremely important, right? So we suddenly have new stakeholders. We have like machine learning AI teams that need to be involved in creating such models. The sometimes no even someone who has no background in data science can build a new chatbot with all the tools. So it's more like a software development problem nowadays. And actually, therefore, you have a new set of people building complex algorithms or complex models and use cases, really. So you have all those new stakeholders. You have new regulatory guidance, such as the EU AI Act, that needs to be taken into account, and that has a lot of requirements that have to be satisfied. You have suddenly a lot more models or use cases actually in your inventory, so you have to deal with that, you have to represent them properly. So all of these are changes that need to happen, but I would argue that changing governance and evolving governance is somehow a gradual process and is something that has a fairly long timeline. On the other hand, we have an extremely fast evolution in the AI system world. You have like new tools every day. You have to deal with huge amounts of data that is often non-structured and that requires proper frameworks and proper tools to manage it. You need to be able to deal with, say, many new releases and updates of your system all the time. And moreover, to the point of the example from the chatbot, you have to like monitor not every quarter verifying that your credit risk scoring models are working, but you basically have almost to monitor in real time that the model and the system is used in the context for which it has been designed. Because if you are working with a chatbot, you can basically ask the Air Canada chatbot, give me a recipe for cookies, and it will give you an example if you do not monitor the context. So you really need to guard the context very carefully, and all of these are really engineering problems. And this is often a topic that is a bit overlooked, because engineering is part of the, say, development, it's part of the first line. But here, what I'm saying is it's really part of the risk management process itself. And that's an extremely important an important aspect of it. So I would really say that every AI risk program should therefore have two parts. On the one hand, you have the governance component. You have to be able to deal with, say, evolving standards, evolving regulation, but you need to also improve on, say, all the engineering that need to happen in order to properly implement all those principles that are required to manage the risk and to stay compliant. So, I mean, this is like a statement. I hope that many people in the audience disagree, and then we can have plenty of interesting questions. But in the meantime, let's go to the next slide. So how do you do this? What do you need to do? Well, there are, say, three extremely important ingredients. We have to make some changes to how how software is developed, how use cases are developed. We have to change or invent a new way of validating those tools. And we have to implement very strict high frequency monitoring. So let's focus a bit on some of those. So first of all, when we develop a new model in, say, traditional model risk management, we always start from, say, the model itself, and that's what's going to be managed. There will be one entry in the model inventory, and yeah, we follow a standard process. In the case of generative AI, it is often the case that actually the use of the model heavily impact, well, actually, that's always the case. The use of the model heavily impacts the risks that are important. And because many generative AI applications are fairly are fairly open, like they are a chatbot interface, for instance, then the context can shift. So that's why when we develop a generative AI system, we need to think in terms of the specific use case and implement controls in order to guard that use case. That's also why you see in many, say, model inventory systems that actually you are going to manage almost like a triplet. You have the system, the AI system, you have the governance that is important for it, and you specify the use, how and what context is the system being used. If the use changes, it's actually a new use case, and you have to basically start all over again. Secondly, since we have so many different systems that are being implemented, the APIs to the model risk management system are extremely important. You cannot manually incorporate all the information in your inventory. It will never be up to date. You need to have, say, API integration so you can automatically like ingest data whenever this happens. And this is related to the third point, which I believe is extremely important. Nowadays, when you have a data science team working on a new generative AI application, if you can, say, make some small modifications to the development process so that actually during the process the information is fed into your model risk management system, then you can also use the model risk management system to actually verify that all the necessary steps have been taken, and you can reach what we sometimes call compliance by construction. What do I mean here? Well, suppose you have a data science team. They will use tools such as CI/CD pipelines to deploy their use case into production. If that tool can verify that the model risk management system that has all the information required to allow it to deploy, then actually you can prove that systems can only reach production whenever all the approvals have happened, whenever all the test cases have been satisfied, and so on. So building those intermediary steps into the development lifecycle is an extremely powerful way in order to reach compliance. Now, turning to second line, to validation, here I think we are talking a lot about being able to measure performance. And of course, performance measurement is something that already happens in the first line as well. But when it comes to validation, it's extremely important that you do this in an explainable fashion. So how does that happen typically? Well, first of all, you need to build reference data, which often means, say, now obviously it depends a little bit on the GenAI use case, but assuming that we are talking about, say, a chatbot type of example, then you need to have a reference data with questions and answers that you know are correct. Now, in order to generate such a reference data can also be already quite a bit of work. That's why most often we start from, say, a RAG type of approach. So what I mean by RAG, this is retrieval augmented generation applications. So these are the simplest GenAI applications where you have a knowledge base. Whenever you ask a question, then first of all, the knowledge base is queried to retrieve information that is relevant to the question, and then the original question, together with all the retrieved knowledge, is passed to an LLM that is going to give a response back. This is a RAG. It's the most simple way of creating a chatbot. But what is important here is that it has a knowledge base. So which means that you can actually leverage that knowledge base to create a set of Q&A pairs that you know are true because you know what is considered to be true. Of course, in other examples, such as the work that was presented by Evalueserve, it can be a bit harder to come up with this type of, say, reference data sets, but it's extremely important, however, that you do set apart enough time to create such reference sets. Now, secondly, then just using only the reference data in order to measure performance is not always the best strategy. And the reason here is that a generative AI application has an enormous dimension. I mean, the space of possible prompts is clearly like quite large, or infinite. So in that case, you need to be able to properly sample the space to have a statistical understanding of how accurate your model is working. So how people normally do this is they then use, say, templates to create multiple variations of the same prompt, and they would expect that the response still remains close to, say, the reference answer. Now, in order to, so the sampling here is a second important point when it comes to validation. The third one is then that when you get the response back from the GenAI system, then of course you have to measure how close it is with respect to the reference answer that you have. Like if I ask ChatGPT what day are we, then I mean somehow Wednesday or the third day of the week, these are like answers that are very close to the actual correct answer. If it says January, then clearly this is very far, right? So you need to have a semantic way of measuring the distance. Very often, people are using other LLMs to measure that distance, but that's actually not an acceptable approach for many model risk managers because you are using one black box to validate the second one. So you really need to think about better ways, more explainable techniques to measure that distance. And here, very often, one reasons in terms of the embedding space. Good. And a last point that I wanted to highlight here is, say, monitoring. So when the generative AI application reaches production, you have to monitor it. You have to verify that, say, the questions that are being asked or the use case that is being put through is close enough to the use cases that were the ones for which the application has been developed. So how do you do this? Again, in the end, it's kind of trying to measure how far are we from, say, the knowledge base of this specific application. So how far are we from, say, the data on which this application has been evaluated, and if you are too far, then actually you need to either inform the user or actually block the response. So having this type of real-time monitoring available is extremely important. And of course, on top of that, there is definitely additional work related to doing periodic review, dealing with updates of the underlying LLM, and so on. So these, I would say, are the three main ingredients to kind of implement efficient governance, and do this by focusing a lot on engineering. Of course, a key component here, I would say even the main ingredient, is to have a team who has the right skill sets. And so if you have suddenly in the model risk management area so much focus on technical tasks, then clearly you need a multidisciplinary team. You need a team consisting of engineers, data scientists, and model risk management specialists working together to do proper validation or to implement a robust monitoring strategy. And that's, I think, say, probably the most important message here, that somehow the skill set of a traditional model risk management team evolves if you want to implement successfully generative AI governance and risk management. Okay, so this was, say, the main topic I wanted to discuss. So let's then maybe turn to the last part of this session, which is to ask if the audience has any questions. So feel free, everyone, to put questions in the chat. While maybe we are waiting for questions to come up, let me already ask a question to our colleagues at Evalueserve. When building generative AI use cases, of course, a crucial point is to have clean data that can be used, right? I was talking about a RAG as an example, but in many other generative AI use cases, it's the same. If, say, the knowledge base is of high quality, if, say, all the information there doesn't overlap, there is no contradictions, that obviously makes the performance of the generative AI use case a lot better. In your expertise, how easy is it to create and capture all of that data, and like what are, say, certain learnings that you have from that exercise? I don't know who wants to take that question first.
I can talk about an anecdote, and then Satya can talk about the data part from the engineering perspective. I think what we do before deploying the client, we run man versus machine competition. And I think that also captures imagination of the users more, which is we continue evolving how the application works, how the prompting works, until it's able to consistently beat the experts in performing its task. So I think that is important part. It goes back to the engineering that Josip mentioned at the beginning. Like, have we done enough thinking at the design stage before it's implemented to make sure it's safe, it gives the right answer, it's actually better than the human? And then we are, and I go back to this, and I think as also was about, and you were talking about the monitoring, I want to say, I think you need one more bullet point, which is that human in the loop, because that humans need to continuously monitor the application in the use case, in the environments, and so we can capture any moments where it strays or feedback into continuously updating it. That kind of that monitoring layer for any GenAI powered application is a complete change versus the traditional thinking of these more, what I would call old school models.
Yeah, absolutely. That's what I meant with periodic reviews, because we don't want humans in the loop in real time, all the time available. It's not always possible to do. But yes, I fully agree. Human in the loop is a super important topic. Satya, anything to add here?
No, absolutely. On data, right? I think in addition to making it contextual, data, like you mentioned, yours is absolutely critical. And it is not easy to get the data right. I think it is getting better, but it's not easy. And there is a lot of work that needs to go into processing the data before it can be even leveraged on LLMs and GenAI. a few examples. There's a use case where we have to extract data from financial reports. So there's a lot of spread data on financial reports that have to be extracted. And to ensure that it's extracting the right data before you can, apply LLMs, and we use OCR technologies, etc. There's a lot of work that needs to go in, to ensure the data is correct, it is tagged right, it is, aligned to the right years and, financials. That's one use case. Similar to that, market data, right? When you look at market data, there's so much noise. For example, I gave the early warning signal use case. You have Jumeirah as a client. It can be a name of a company. It's the name of a place. It's the name of a tower. How do you ensure that it's the right context, right? So I think LLMs are also making it easier to collect data, but the data needs to go through multiple levels of processing before it can be used. Even the technologies that are out there, cognitive technologies out there has to be an engineering layer over it to make it a lot better to extract data. So it is not easy. And I think that's where, the role of domain experts and engineers come in as well.
Yeah, right. Very good points. Maybe another question I got here is, like, we talk a lot about human in the loop, so ideally, how do you efficiently implement human in the loop? Because ultimately, you want to ask an expert only when there is enough uncertainty in the response, right? So how do you practically do this? Do you calibrate this? How do you measure uncertainty? How do you make the decision that a human is required?
I think that is an excellent question, Jos. I wish you didn't ask it, it's so good. But I think there is not one single answer on how that person in the loop can be included. A lot of the processes that we support really are expert driven. So they're very heavy domain as they are, right? We talk about the credit memos, we talk about insurance underwriting, underwriters famous for the domain that they bring to the process. We talk about corporate action adjustments and index calculations. There is a lot of domain that is needed in that process, and I think that's why when you talk about the business use case, for these processes, the process becomes AI augmented as opposed to straight through process using GenAI. So it's a different use case, and I don't think we have enough confidence in this technology just now to rely on it purely. And I think that expertise will be needed going forward. And it is about designing the process, designing the workflow, designing the user interfaces. I go back to that user interface that we showed in the little video, which is every answer proposed by the GenAI gives a confidence level, but it also suggests, okay, where it came from, why do I think this way? And the human can, it's what we showed you there for insurance. For a human to run the search and complete what the GenAI was doing was taking on average 14 hours. It takes the machine 3 minutes, right? So I think it's not a bad outcome if a human can spend 5-10 minutes verifying that this is all correct and completing where it's not completed. So keeping that balance right and focusing the technology on the use case when that ROI is positive, acknowledging that there is governance needed and that there's a cost of that governance, as you spoke about.
Yep.
Because getting it wrong is very expensive, as Erica has discovered.
Exactly. And then maybe a last question from the audience about, say, what is the efforts that you need to spend on validation and monitoring kind of similar when it comes to generative AI effectiveness? That's also a very good question. I would say the role of validation and monitoring is slightly different, right? Validation is really verifying that the model, the use case is fit for purpose. And you do this at very specific moments in the life cycle. You really do this when when you want to move into production for the first time, whenever there was a large modification to the internals of the algorithm, or when the use case changes a lot. Monitoring, on the other hand, you do continuously, and ideally you do it in a highly automated fashion. But of course, indeed, to your point, Anna, you need also from time to time to review as a human the results of that monitoring exercise. And you would have to do this more often when you suddenly see a peak in issues that are being monitored, and you typically do this a bit less often. If everything is always working as it should, and you do not trigger a lot of action. So I would say, if you do monitoring, it's probably, and monitoring is definitely a lot lighter than a full-on validation. But on the other hand, if there is a lot of changes in the underlying algorithm or in the underlying use case, then you will see certainly peaks in the monitoring activity, which then again triggers more validation, I would say, afterwards. I don't know, Satya or Anna, if you have anything that you would like to add there.
So we do, for some of the applications we have in production, we run the team can correct me, I think we run a review every 3 months and the recalibration of the model every 6 months. And that is recalibration every 3 months. So that the frequency is definitely higher. Maybe once we get into the, it's been in production for much longer, we will see a relaxation. Now we've done 3 cycles of recalibration. We are looking at the stats of how much of that recalibration is happening, what's changing. But it's a different process. It's a different beast. Someone asked, is the same effort to ensure GenAI effectiveness? I think it's a different effort.
Yes.
That's why that business case needs to be firm, and we have to be confident it works. And I think that's one of the reasons why there is so much interest in the industry of what is the use case someone has in production. Does it work? What is the cost? Because to run a lot of POCs is excellent, but to turn it into a situation where it's in production and delivers value and the governance is right is not a easy process. And having a partner who has traveled that journey is an important part of getting it right quickly.
Okay, thanks a lot, everyone, for this very insightful conversations. Thanks to the audience for joining us and for asking all of those insightful questions. I'm sure there is plenty of new topics to discover. There is definitely a lot of value in generative AI. There's some challenges, and it will always be interesting and worthwhile to review what can be improved and what is going well. So thanks, everyone. Let's definitely stay in touch. Bye for now.
Thank you, everyone. Bye-bye.
Bye-bye.
Thank you. Thank you.
Thank you.